She was a raging lefty, and she went, "The world needs more leftists." In my ear when she went, but I drove away. Like, yeah, you have to whisper, don't you? Because you're American. There, you say it out loud, they'll shoot you. Anyway, right, okay, going live.
Chatting up those Yanks.
Yes,
Chatting up those Yanks.
she fucking loved Coco. She loved Coco. She didn't know the scooter was mine. We went in. I was sat in there, and I've got video of Coco singing. Ooh, echoey in the cathedral. And she came over to see the dog, and she was all brilliant. And then when we went outside to get in the scooter, she was going, "This is your scooter? I got a scooter 20 minutes ago." And I was like, "Wow, what amazing." I was like, "Oh, Jesus Christ." Really annoyingly positive. But I like her. She was nice.
Oh, bloody hell.
A, bounce, a bouncy, blonde, positive American girl. What more do you
Nothing
need?
like them. Nothing like them.
Bouncy, bouncy. I mean, a lot of bouncing to do.
All
Right, I'm
right.
eating.
Welcome to Dis and Dat. I'll try and get over this because I really do want to see what Lane has produced in his latest sojourn. Anyway, welcome to Dis and Dat. 6 March. Well, anyway, it was Ash Wednesday, I think, yesterday. Uh, Back to catastrophe theory today. I mentioned catastrophe theory a couple of times before, but I've never fully kind of explained it. I showed a couple of diagrams and sort of hinted that's kind of where I was headed. So this is a little bit more in that direction. And yeah, I'm sparing you the math. There is math though, but it raises an interesting question about the difference between qualitative and quantitative, but that's for another story. So, in mathematics, catastrophe, well, the thing about catastrophe theory in general is that it got real popular. Everyone started using it, like the expression paradigm shift, which is not exactly, it's not used that way in at least American English very well. Most people think it just means changing theories, when in fact it's really about an entire belief system or an ideological change that does more about how change occurs in science. But no one wants to talk that way because it's got too many syllables or whatever. So, in that same vein, in mathematics, catastrophe theory is a branch of bifurcation theory, that is, dividing things up. In the study of dynamical systems, it's also a particular special case of more general singularity theory in geometry. Rene Thom developed a catastrophe theory in the 1960s. Yes, there was a 1960s, which studies how small changes in parameters can lead to sudden and significant shifts in the behavior of dynamical systems. Noting, of course, that parameters are not perimeters, and that's often, and most of our problems are kind of at that level, not so much as an actual conceptual level. Now, what's a general singularity theory in geometry? Singularities are ubiquitous in mathematics and science in general. Singularity theory is a crucible where different types of mathematical problems interact, surprising connections are born, and simple questions lead to ideas which resonate in other subjects. So that's kind of why I'm doing this. The same, my little research question, it's not a full research question, obviously, but a little one, a tiny one. Can Fauffret, that is, false costs, describe those kinds of small parameter changes? Now, catastrophes are bifurcations between different equilibria or fixed point attractors. Now, what's a fixed point attractor? That's a whole nother story. But anyway, due to their restricted nature, catastrophes can be classified based on how many control parameters are being simultaneously varied. That's a heck of a way to talk about something that's a catastrophe. For example, if there are two controls, then one finds the most common common type called a cusp catastrophe, and you'll see that in the diagram. If, however, there are more than 5 controls, there's no classification. That's an interesting, speaking of parameter. Catastrophe theory has been applied to a number of different phenomena, and that's the interesting thing because it got very popular. But then, as some people have described it, it kind of got overproduced. People started applying it to every damn thing out there, and so it kind of lost, you know, kind of its authenticity or credibility because people started applying it to all kinds of stuff, and in many things, it doesn't quite apply, such as the stability of ships at sea and their capsizing, bridge collapse, and with some less convincing success, and that's the issue, the fight or flight behavior of animals and prison riots. Now, you can see how catastrophe could be applied to prison riots, but it just, because of all the because of the type of variables, i.e., prisoners, etc. A prison riot, to be able to predict a prison riot using catastrophe theory does seem a little, how shall I say it, stupid. In this paper, after studying some properties of attracting fixed points, this is to explain attraction for fixed points, we focus on the conditions in which a fixed point becomes an attractor. And the results are as follows. Number one, the fixed point of a system is an attractor which, when a contraction map of a locally compact metric space or an ultimate contraction map of a compact metric space. And number two, with respect to one kind of weakly contraction map of a compact metric space, a necessary and sufficient condition of attracting fixed point is provided. So that tells you nearly nothing. On the other hand, when we get to PowerPoint slides, small changes in certain parameters of a nonlinear system can cause equilibria to appear or disappear, or to change from attracting to repelling, and vice versa. Now, that's an interesting idea. That just the fact that things might come into view and then suddenly disappear, and that's sort of an interesting idea. And speaking of it, when you start applying it to the Zeeman effect to magnets or magnetic force or whatever, I think that's sort of interesting too, because it is a matter of appearance and disappearance, leading to large and sudden changes of the behavior of the system. However, examined in a larger parameter space, catastrophe theory reveals that such bifurcation points tend to occur as part of well-defined qualitative, not quantitative, but qualitative geometrical structures. Now, what does that all mean? Well, I just decided to just punt and let Gemini define for me what a well-defined qualitative geometrical structure. So it's a description of a shape or spatial arrangement that focuses on its essential non-numeric properties. That means that you're kind of looking at graphical things as opposed to trying to measure them with numbers. So topology, how parts are connected, the presence of holes and overall connectivity, whether you as a person are a topological, cylinder or whatever. Uh, Relative positions, inside, outside, adjacent, above, below, before, and after. And that has a lexical implication, Um, often our inability or ability to learn a language has to do with those kinds of, kind of spatial things. Shape characteristics, descriptions like curved, straight, angular, smooth, rough, convex, or concave, and structural relationships, how different parts relate to each other in terms of their overall organization. So it sounds formal in that sense. So the description is unambiguous. It should be possible for someone else to understand and recreate the structure based on the provided information, even if they don't have precise measurements. So that's kind of what that's about. And it allows you to define specific kinds of structures, and it depends on things. It avoids precise numerical measurements like lengths, angles, and coordinates, which is, of course, incredibly problematic when you really want to actually apply it to the world. It focuses on descriptive terms and relationships, which makes it all the more conceptual. And it emphasizes the overall form and arrangement rather than exact dimensions. Now, the whole point here, of course, is to kind of bridge this qualitative quantitative gap because, in fact, that's what we always have to do. And it always is problematic when people try to say, well, it's all about numbers. And then when they give you a graph of the thing, they say it does this and that and the other thing, and it really doesn't because you never understood the math. This is the basic problem in teaching economics. But anyway, so and it can be applied in a variety of things. Computer vision, that's in terms of spatial recognition and also kind of how you recognize shapes in space, because shapes in space are generally 2.5D rather than 3D when you're talking about a computer vision, and at least from um, a human computer interface, and then GIS, geographic information systems, describing spatial relationships between features. That is, the river flows through the valley. And then robotics. Um, Navigating and manipulating objects based on their qualitative properties. In other words, look for a shape that is, box-like or whatever, and et cetera. So you write an algorithm that does that. Architecture and design, conceptualizing, communicating spatial arrangements, and then mathematics, of course, topology and geometry, formalizing the study of shape and space without relying on measurement. You see, there's this moment, and that's, of course, the interesting problem of when can you bring these things together, or at least that's kind of my little thing. And so, if someone were going to draw it out, and this is a kind of very crude example done with, I think, dry erase um, markers of the stable surface, you can see there on the top. The unstable surface is where the cusp, well, there's the cusp, and then there's this flipped side underneath it is unstable, and the catastrophe is defined by that distance between that lower band and the upper band of the this little warp in the equilibrium surface. And now you can see that it can be applied to all kinds of stuff. So there's an attempt to apply it, for example, to physiology or to sports, and to put a performance surface, a physiological arousal, a bifurcation set, a cognitive anxiety, and it's trying to explain, in fact, sort of the performative burst that allows you to succeed. Um, that's taking it perhaps a little far. Similarly, this is a even more intense version of trying to um, build it into the way in which to describe or talk about performance. You see, that's where I think the moment when catastrophe theory went sideways. Now, on the other hand, in a archaeological sense, uh, in a broader kind of Stephen Jay Gould sort of way, you can actually talk about punctuated equilibrium. So without getting into the idiocy of this, there is state, time, and stress, low, high, primitive, advanced, and you can see that various fossil things, there's a gap, right? Now, without trying to claim that God is there or something, these gaps, these performative or whatever, an anagenesis is kind of an interesting thing or idea, and it's a thing that Stephen Jay Gould sort of was fiddling around with on in terms of talking about evolution. So that's actually a very interesting idea, and applied to the fossil records, that kind of allows us at least a little bit in terms of punctuated equilibria hypothesis. So without getting into all of that, now the more direct application, which made it very popular, of course, is to say, well, um, maybe we can analyze business stock markets, maybe not so much business, but stock markets, and there's I have a PowerPoint thing that talks about Zeeman, the Zeeman theory applied to partially to a bunch of things, but one, it includes an analysis of stock markets. So is Rutherford qualitative? Is just bad quantitative, which is one way that many people put that, right? That um, people who work mainly with numerical stuff, real analysis, et cetera, sort of poo-poo the idea of qualitative measures because, oh, well, just it's at the surface, it's a curve, it's vague, blah, blah, blah. Uh, it's kind of incomplete when you think about it in the numerical sense. But anyway, the geometric optics model can be shown to be a limit of the quantum mechanical model. And that gets really a little far with the stuff. But heuristically, that is to talk about a sort of standard model to kind of assume to that from which we can work. Does it have any value? That's an interesting question. That's kind of the question I'm asking. In particular, does a heuristic of the stock market, that's not what I'm interested in, but it is one that has been applied to the stock market, have predictive value? Now, I'm just less interested in the predictive value. I'm more interested in the kind of hysteresis, that is the historical element of of models. So how is it that you measure and the market adjusts? So it's a lot more out of control. And so the bigger question is science about making models, which is actually an interesting it's a much bigger theoretical problem. So um, this guy Zeeman, um, who builds on work by Huygens and a bunch of other folks, actually builds a catastrophe machine, and and writes all kinds of interesting articles. So I've only just started on this, but I think he'd just be an interesting person to look at for a while, just because he's looking at all kinds of crap. Um, he's thinking about ship stability, wavefront models, brain modeling, the unstable behavior of stock exchange. This is where, a catastrophe idea, on the one hand, could be applied. On the other hand, it's it may not this model may not have its be that useful. Anyway, here's that our same little flip here, and in the application to the stock market has bull and bear kind of, and you could sort of do that naming, but does that get you anywhere? That's an interesting question. um, but Siemens' argument is that a feedback mechanism explains why crashes are more common than frenzies. So, okay, uh, it just it just describes a tendency and doesn't necessarily get you anywhere. On the other hand, he actually made a little wheel that does mathematic or physically the same thing that the math does, and that is you get a couple of rubber bands and connect them to a wheel. I'll show you the diagram in a second, and how it operates, and I'll hopefully I can show you how that works. But this is a much more fancier version of it to show the way the surface operates, and it's quite beautiful in that kind of mathematical way. And of course, there's a reflection. This other thing down here is the other part of it that becomes more interesting. Now, where it can go crazy, of course, is applying it to all kinds of stupid stuff. That this is panic, this is calmness, this is a somatic surface, numbness, the cusp is some sort of neutral ambiguity, and mindlessness and mindfulness are down here. This can make you nuts if you really think that it's designed that way. But you could go there. Not that that's necessarily where you should be going. So let's look at it in the Zeeman wheel as it sort of operates. It's only 30 seconds, so you don't need to go crazy. So if you take two rubber bands, this is what happens. The moment it switches, right? That's the little catastrophe. Zap. That's the catastrophe. Anyway, so it's as simple as that. Um, Here's the way in which you can do it physically. But it has math. I mean, and yet it's got rubber bands. So that's kind of amusing. When we start evaluating what is catastrophe theory, it's very easy to be led into the wrong conclusions just for terminological reasons. Of course, many people know that already, that in catastrophe theory, the word catastrophe does not have the sinister meaning it has in everyday language. But few people realize that the word theory itself has to be understood in a peculiar sense. It would be completely wrong to equate catastrophe theory with one of the standard scientific theories, like Newtonian theory of gravitation or the Darwinian theory of evolution. Although I just showed you that can have an effect relative to this punctuated equilibrium idea. In such cases, one has to expect that the theory has to get some experimental confirmation. It has to be founded, or at least maybe falsified in Karl Popper's sense, by experiment. And that's the big issue for challenging Marxism and Marx's labor theory of value, which, as we've tried to say, is not everybody subscribes to it, and we've sort of transcended that. In fact, maybe we shouldn't even be talking about it in that way. But yet, there will be discussions of Marxism and catastrophe, which we'll get to in a second. The plain fact is that catastrophe theory escapes this criterion. It cannot be proved, nor falsified by experiment. And that's the interesting question. I owe this fundamental remark to a British biologist, L. Wolpert, who once in a meeting told me, your theory seems to be able to explain everything. But a theory which explains everything explains nothing. After some time of thinking, I had to accept this objection as perfectly valid. Being aware of this fact, we could try to find a way out by saying that catastrophe theory is a quote unquote mathematical theory. Here again, I'm afraid this statement is not correct. Of course, catastrophe theory deals with mathematical theories and mathematical objects. It has led to many interesting results in differential analysis, theory of smooth maps, and bifurcation theory, qualitative dynamics, etc. So, in other words, you can get a result. It is problematic to, you have to sort of refine your theory, and it is one of the problems of, the difference, particularly in the social sciences, between qualitative and quantitative, and trying to raise the credibility of one versus the other, and blah blah blah. And winnows down to in some fields to cultural studies approaches versus political economy approaches, but that's getting pushing it a little far. Now, so there's a kind of major article. Well, the major article is Wagstaff, but this is Day and Tivers probably is a reasonable one for yakking about Marxist stuff. So, catastrophe theory and geography. This is just the summary and sort of the front end, the first page. Catastrophe theory and geography, a Marxist critique. Catastrophe theory provides a useful approach to the description of discontinuities in behavior in both the physical and social sciences. But the Marxist theory of dialectical materialism presents us with a suitable philosophical base for the explanation of such discontinuities. That's kind of what we're driving at here. This is the point. And I'd like to say that faux frais is a way of getting at it. So here's the front end to this a Marxist article on catastrophe. Recently, geographers have begun to show interest in catastrophe theory. Wagstaff justifies this interest in terms of the way catastrophe theory encourages us to go beyond the modeling of continuous processes, broadening our approach by allowing us to include discontinuities within models. However, it is generally accepted that the theory at present cannot normally be used for prediction, particularly in the social sciences, but only for descriptive modeling of qualitative changes, which is what I've been yammering about up to now. This has been admitted by both Wagstaff and Thom, the originator of the theory, Rene Thom, as I said. Catastrophe theory thus enables us to model discontinuities without necessarily being able to understand the reason for them. It is the object of this short paper to suggest that the Marxist theory of dialectical materialism, particularly the concept of the dialectical leap, can provide the philosophical base for this understanding. Catastrophe theory is fundamentally concerned with the relationship between quantitative and qualitative change. Quantitative change and qualitative change. It deals with the fact, and often observed by geographers, that a continuous process, quantitative change, can operate within a system producing no noticeable change in its form until a sudden qualitative change takes place, commonly conceptualized as reaching a threshold. An example used by Wagstaff is of a landslip where continuous processes operating on a hill slope produce the sudden landslip, right? Landslides occur. Yeah. And there's lots of models for this. Sandcastles have a similar kind of problem. There's a bunch of neat articles on why sandcastles stay up and don't stay up. But anyway, catastrophe theory is concerned primarily with mathematical modeling. Traditional procedures for modeling change derive from the calculus of Newton and Leibniz. While adequate for describing phenomena exhibiting smooth behavior, that is, continuous change, offer little value when faced with systems having sudden discontinuities. The latter would require the writing of equations to describe each side of the break. In contrast, catastrophe theory provides a topological means of incorporating discontinuity into models. Now, the methodology of catastrophe theory is the observation of a system's response to alterations in its parameters. Wagstaff chooses the example of boiling water to illustrate the response. First, the parameters of the states of a system, and in this example, density, pressure, and temperature for boiling water, are established. Then one of the controlling variables of the system, in this case temperature, is altered. The changes in state produced by altering the variable are observed, and a topological surface is produced to represent these changes. Thus, one is concerned to describe the effect of changes in control variables on the form or appearance of the system. Now, that's the first page, and you can see how it could move on from there. And if we were going to argue against or for a value form theory of Marxism, it could be precisely this problem, which is one that seems to confound scholars. And maybe yes, maybe no. But, we continue to hack away at the problem. And I came across this great article, probably an article that I probably needed to wait the decades, 5 decades to get to this article by Mohammed Mustafa on 5 decades of catastrophe theory research, geographical analysis, knowledge structure. And so um, this one will make you crazy if I read it, but let me give you the general idea. If you use a bibliometric network technique, you can talk about how many, the whole issue of how many authors wrote about catastrophe and how is it that you can sort of see, you can actually map it out, where did it go? Where did all that? You can follow the sort of the detours, the the dead ends, and all the kinds of counting of all of where catastrophe theory appears. And you can see it's applied in a variety of journals, not only behavioral science, but ecological modeling, physical chemistry, theoretical biology, etc. So you can see that there's all kinds of stuff in there. So let me give you the basic introduction, and this is from an article talking of making bibliometric analysis, that is, trying to count and map all the places that catastrophe theory has been for the last 50 years, which is easier than trying to do it yourself, and it just saves time, kind of like AI saves time, but you sort of need to know what's going on in order to estimate whether you did or you didn't save time. Catastrophe theory, a branch of non-dynamic mathematics, was first proposed by René Thom, to study phase transitions or morphogenesis. Guastello defines catastrophe theory as a special topic within the broader domain of nonlinear dynamical systems, NDS, that pertains to sudden discontinuous changes of events. Examples of such discontinuous changes include phase transition in physics, sea waves, progress towards the shore, and sudden changes in behavior. Now, that's pretty interesting to even draw a similarity amongst all those things. Thus, catastrophe theory belongs to a broad NDS, nonlinear dynamical system inventory, which also includes chaos and fractals. Phase transitions or catastrophes occurs whenever a continuous and smooth variation leads to a discontinuous and disproportionate variation of effects. Due to their complex transition density function, catastrophe theory models proven analytically intractable. Now, the point is that, sure, theory models of this type are problematic, indeterminate in some ways, but it still doesn't mean we can't sort of look at them and think about what relevance they have, because we have exactly the same problem if you're trying to measure, let's say, to use a different example, a paradigm shift, the one I used before. Measuring paradigm shifts is actually an interesting empirical problem and actually worth historically testing. I'm not doing it, but I assume someone's going to do it or has done it actually. And that's an interesting problem if you're going to try and do that, so that to make it analytically tractable in that sense. A catastrophe is characterized by the presence of 5 elements. A, bimodality in the distribution of the outcome variable. B, abrupt or sudden change in the outcome variable. C, the area between the modes is inaccessible. That's that little whip in the surface, indicating that it's unlikely for an outcome value to fall in this area, It's kind of like a Bermuda, think of it as a Bermuda Triangle, maybe. D, the temporary change from one mode to another is random hysteris, hysteresis, actually. And E, divergence, which implies that a slight change in the control factors can lead to substantial change in the outcome and deviation from the linear model. Seminal works by Cobb, Cummins-X, et cetera, helped in popularizing the application of catastrophe theory, which led to a plethora of applications, which is what I just described. However, despite the proliferation of catastrophe theory research, to the best of our knowledge, no bibliometric analysis was conducted to examine the conceptual, intellectual structure of this burgeoning field of research. And yet, et cetera, et cetera. And so they're kind of raising the question in this article, how did the scholarly catastrophe theory research evolve over time? Who are the most influential authors shaping the landscape of catastrophe theory research? Well, like Tom and Wagstaff, et cetera. Which journals publish the core catastrophe theory research? What are the major themes and trends? So it's all kind of librarianship in that sense. How scholarly catastrophe theory research, collaborative networks between authors, et cetera, et cetera. So an excellent article because it does talk about 50 years of research and kind of makes the job easier. Let's put it that way. And in fact, with all due respect to AI, it is essentially how you would build an AI system to answer certain types of questions, which is how it does that. Now, there are other contributions, and ones that get more closer to the Marxist things are here. For example, here's a little piece. Economists haven't thought about the catastrophe. We should ask ourselves, why not? History has witnessed enough devastations suitably economic that have led our society to the fringes of chaos. The German hyperinflation of 1923, where you needed a wheelbarrow of Deutschmarks to buy a loaf of bread. Major financial and banking collapses like that of 1929. Now, open crisis that began in 2007, which we have looked at extensively, Hudson et al., could have potentially carried dislocations of this magnitude. It's difficult to concretely imagine what would have happened had the euro collapsed, which almost happened in autumn 2011. And indeed, perhaps this is a story that remains unfinished, and that is definitely possible. And the it may be, in fact, that that's why Trump is crashing the American economy, so that at some moment pressure will be made and the euro will collapse as well, which will be an interesting issue. Wonderful things yet to come. Yeah, as if the economic order of things were postulated by an intrinsic regularity, or rather only admitting reasonable irregularities. Economists seldom have at their disposal a concept other than that of crisis. Now, what can they offer in the name of catastrophe? Perhaps a terminal destruction of the institutions of the capitalist economy. That is to say, the annihilation of their object is the reason why the catastrophe remains of the order of the ill-considered, if not of the decidedly unthinkable, en pense. Um, Therefore, there will be continually only the crisis. Furthermore, do economists really think about it? So that's an interesting question. No one wants to talk about it. And defining a catastrophe would be an interesting moment. Just casually speaking, of course, anecdotally speaking, people want to say the moment when whatever, and in fact, I tried looking for it the other day and I couldn't find it. The moment when a broker jumped out a window. This defenestration stuff is actually kind of interesting considering Russia at all, but that's what the stock market crash. The stock market's crash. The stock market crashes relation to suicide rates, for example. Now, here's Marx's view on this. So we can quote, of course, in our little inerrant biblical way to Marx and Capital on this very thing. The other expansion here related to the presentation of credit. The reason for this may have been the crisis of 1866, from which Marx retained that it has, quote, a predominantly financial character, as he mentioned in a short note in the first volume. Quote, its outbreak in May 1866 was signaled by the failure of a giant London bank. immediately followed by the collapse of countless swindling companies. See Lehman Brothers. One of the great London branches of industry involved in the catastrophe was iron shipbuilding. The magnates of this trade had not only overproduced beyond all measure during the swindling period, but they had, apart from this, entered into enormous contracts on the speculative assumption that credit would be forthcoming to an equivalent extent. A terrible reaction then set in, which continues even now at the end of March 1867, both in shipbuilding and in other London industries. So you can see that's a catastrophe is being described here. Now, the point that you want to make as a revolutionary or an activist or something, will this bring a revolution? That's the point at which you want to metaphorically say, well, does the catastrophe enhance the crisis or whatever, or in fact, does it neutralize it in some ways, which is kind of what you sort of need to think about, and when you kind of consider the whole literature of Marxist crisis theory, which does there is a literature, it's pretty extensive, and you do want to sort of see how it relates because it has all those other elements in it. That is the tendency for the rate of profit to fall, blah blah blah. And the various collective ingenia, the worms, may be affected differently by a single economic condition, and one collective ingenium can be affected by a single economic affection in different ways at different times. What are the collective effects of the condition of the credit crunch? What will the economic downturn and austerity policies produce? This is the question that remains hanging. The becoming crisis of this situation, which is to say, the contingent birth of a collective of passionate dynamism with sufficient power to achieve a transformation of the political institutions of capitalism and a change in the regime of accumulation. That's the whole point, of all this left stuff, is that probably need to change capitalism in some way, maybe get to socialism or a kind of socialism and change the regime of accumulation that is the current thing where some nut in charge of with the hands on the lever of the economy is making money for himself and not redistributing it by any means at all. Similarly, the question of whether the present state of the economy qualifies as a crisis in capitalism, i.e., where the stakes would be delimited by the passage from one regime of accumulation to another, or as a crisis of capitalism, remains totally open. Nothing can exclude, and yet nothing makes it necessary either, that the question of capitalism itself and the opportunity to surpass it is biased in favor of existing disorders. A simple crisis of the regime of accumulation could mutate into a crisis of capitalism itself if, as a result of these economic affections, the idea of forming a majoritarian affective ideation crossing the intolerable threshold is understood as having to do with capitalism itself. And if one day this terminal event is to occur, it will first take on the guise of a crisis of the regime of accumulation, in some ways the crisis of too much, packed with effective amplification of unprecedented intensity. A critical dynamic is launched only by the formation of collective power determined to transformative action. And this formation of power itself is only constituted under the influence of common affects that are sufficiently intense. These affects have to do with the limits of the intolerable. What cannot last any longer? But the extension of the what is the object of judgment, and the intensity required for it to be judged can no longer continue or immune from a certain a priori knowledge. When the conditions of economic affairs transform themselves into a crisis, they demand the knowledge of what effects these affections will produce. For their fortune and their misfortune, power lives in this uncertainty. Power shelters in the plasticity of the social body, whose tolerance and capacity for accommodation can extend a remarkably long way. Or the social body lives under the perpetual risk that its ability to cross the invisible threshold is already realized too late. That since the subprime bubble burst in 2007, 5 years of serious economic chaos has not decided on the final orientation of affairs. Well, we're farther along than that. The question that remains open is whether this set of economic and social conditions will be determined by the lack of large-scale collective movements and will instead only give rise to individual sorrows or sporadic movements without results. Put another way, the result of collective affects yielding only limited concessions in the style of Roosevelt's New Deal, which remains in capitalism by reconfiguring the regime of accumulation. Or instead, triggering the formation of a collective revolutionary power, the catastrophe. Um, so this is a little article on, or actually, well, it's almost book-like, but it's a pamphlet on catastrophe. So we're at the end. Thankfully for all you folks, there is a literature for this. I hope that I've at least given you a little sense that this all has a certain structure to it, and it has it has analytic capability, and it's there are ways in which this can and should be studied, and or if not, just simply rationalize our fiddling around with these ideas. And so, kind of that's where I'm headed. So, I appreciate your attention to my fiddling around with this idea, which I had introduced many, many months ago as a fleeting notion, but I thought I'd get back to it and look at some of the more bibliographic, the literature review stuff. Because if I get anything written, it'll probably have to have all this crap built into it anyway. So anyway, that's it for today. Oh yeah, somebody quoted my little grok thing, or not mine, but there's I quoted it the other day in my writing of the likelihood Twitter's AI called Grok estimated 75% to 85% likelihood. Speaking of chaotic algorithms, that Trump is a Putin compromised asset leaning towards the higher end of that range. Now, it'll be interesting to see whether uh, Musk suppresses that or just leaves that in Twitter, but that is a thing that you can actually get from the Twitter AI that describes that. And I would hope that people have started to consider that more closely. So yes, the Scooter, the catastrophe machine. There we go. Okay, so enough of my stuff here. I will stop the live stream. So